We'll be learning about bonding and equations. So to get started, what is chemical bonding? So I want to ask you guys a few questions. So do you know what a chemical bond is in chemistry? If anyone knows or would like to take a guess, please just unmute yourself. Yes, Ms. Skeen?
I think it might be like when two different chemicals like combine.
Yeah, it's actually when two atoms have an attraction to each other. So yeah, in a chemical bond. So pretty good. And the next one is, what do bonds connect together and why are they important? Yes, Nikhil?
I think they connect atoms and specifically the electrons. And I think they're important because they keep all the molecules in the world together.
Yeah, exactly. So they do connect the atoms together kind of through electrons is kind of like how they do it, but we'll learn more about that later. And they're actually important, not only because they keep the molecules together, that is true, but also because bonding creates new substances, right? So when you combine two different atoms of different elements and you combine them together in a bond, they can create something completely different, a completely new substance. And if you remember a few weeks ago, we learned that there's only 118 different elements in the periodic table, but through bonding, we can create millions and millions of different substances, which is really cool, which is why bonding is very important. So the next question is, how and why are bonds made? So atoms bond with other atoms based on the number of outer electrons they have. So a few weeks ago, we learned that there's a positively charged nucleus, and then there's atoms that kind of orbit the nucleus, and they orbit it in different levels. But again, these bonds have to do with how many electrons are in the most outer level. And basically, all atoms want to have exactly 8 outer electrons. That's just stability, right? And so to get those 8 magical electrons, atoms will share, give, or take electrons through bonding. All right, and so here's a quick review of the periodic table of elements, which we learned about a few weeks ago. So we can determine the number of outer electrons based on which column an atom or an element is in. So the first column will have 1 outer electron, and then the last column will have 8 outer electrons. And we can also see that we usually skip the transition metals, but skipping them, we can see that the last digit is how many outer electrons they have. So here we have 1, 1 and 2, so 1 outer electron, 2 outer electrons, and then we skip to 3, 4, 5, 6, 7, and 8. All right, and then I want to ask you guys, how many outer electrons does nitrogen, symbol N, have? And so again, we can find that out by looking at the second digit of the group number or column number. So can anyone try finding nitrogen and then seeing maybe how many outer electrons it has? Yes, Roshan?
5?
Yeah, exactly. So nitrogen does have 5 outer electrons. Oh, really awesome. All right, and then let's continue our review. The elements are split up into 2 different categories, metals and nonmetals. Right, and in the periodic table, we can see that the metals are in dark blue and the nonmetals are in light blue. And these categories determine what types of bonds will be created, right? So atoms of metal will not bond with each other. So basically, the 2 types of bonds that we'll talk about today are ionic and covalent. Ionic bonds will only form between metal and nonmetal atoms. And then covalent will bond between 2 nonmetal atoms, right? But there's never 2 metals bonding together, right? You won't see like iron and cobalt. They just won't go together when it's just them. So again, ionic is metal and nonmetal, and then covalent is 2 nonmetals. And again, these bonds are formed through chemical reactions. So any questions before we start talking a little bit more specifically about ionic and covalent bonds? All right, doesn't look like there's any questions. So in an ionic bond, a metal will give an electron, or maybe more than one, to a nonmetal. So an example of this is table salt, or sodium chloride, will form when sodium gives chlorine its only outer electron. So if we look at this diagram, we will see that sodium has one outer electron and chlorine has 1, 2, 3, 4, 5, 6, 7, 7 outer electrons. So sodium gives away its outer electron, and suddenly they both have 8 outer electrons. So they're both happy. But when you just give away an electron, they tend to be attracted. They stay together. And also, because technically sodium lost an electron, it will be positive, and chlorine, which gained an electron, will now be negative. But again, they remain bonded, and that's what table salt is. So pretty cool. And then the other type of bond is a covalent bond. So within these bonds, 2 nonmetals will share their electrons. So here we can see 2 chlorine atoms, and then they combine, and they share an electron, right? They both have 8, without completely giving away or losing an electron. All right. But also what's important to remember is that they don't have to be in the same element. As you can see, there's 2 chlorine atoms, but they can be from completely different elements. For example, water, which is hydrogen and oxygen, are the 2 different elements in water. They're 2 different, but they're also covalently bonded. So covalent bonds happen between 2 nonmetals, and then ionic is 1 metal and 1 nonmetal. And then the next question is, how can we determine whether a bond is ionic or covalent? So typically speaking, ionic bonds are much more likely to dissolve in water. For example, table salt, as we know, does dissolve in water, and it is ionic. All right, so we're going to be moving on to our first activity, which is we'll be creating our own invisible ink. So the objective is that we will understand the reaction between lemon juice and air that enables the writing of invisible ink. Cool. So here are the materials we will need. We'll need half a lemon, a spoon, water, a bowl, a Q-tip, paper, and a light bulb or a lamp. So take a few minutes to get all these materials ready, and then we'll have a cool experiment. Okay, so I think we are waiting for Nikhil, but I think he is getting the materials. So while we wait for him, the first step is to squeeze half a lemon and add a few drops of water into a bowl. So again, we're gonna if you have, oh, hi Nikhil, do you have all the materials? Awesome. So again, I just told them that the first step is to squeeze half of the lemon into a bowl, and then maybe add a few drops of water, and then stir that all together. And then when you're ready to move on, just give a thumbs up. So as we're wrapping this step up, it's okay if you're still not done squeezing the lemon, just take a few more moments to do so. The next step is to soak the Q-tip into the lemon water mixture, and then write a secret message on the paper. But again, if you need, you can continue squeezing the lemon. Yes, Nikhil?
Would a flashlight work as a lamp?
I'm pretty sure, yeah. Flashlights should work fine. Has anyone gotten to the step where we write the message yet? All right, so I think we can move on. So we're gonna wait a few seconds for the lemon juice to dry.
I have a question.
Yeah, what's up?
When we write it, do we put a lot of lemon juice on the thing or a bit?
I would put maybe a medium amount so the whole paper's not soaked, but I would say more is better than less. So we'll wait a few more minutes for everyone to write down the message and for the lemon juice to dry. And then once it's done drying, just give me a thumbs up. But I think we are ahead of schedule, so there's no particular rush. All right, and again, just give a thumbs up when your secret message is written and it is currently drying. All right, and it looks like I think Roshan and Nikhil went to maybe get some materials, so we'll wait for them. But the next step is to put the message, actually wait, no, we'll wait for them. Don't want to give the results away. Okay, so I think we will continue. I'm not sure where Nikhil and Roshan are, but the next step is to put the message really close to a light source. So that can be a light bulb, or I think a phone flashlight might work. Oh, hello, Roshan. So this is the next step. We're going to place our secret message really close to a light bulb and see what happens. And if you are using a real light bulb, try not to touch it because they can get pretty hot sometimes. So yeah.
I don't really see it. It doesn't really seem like it's working too much.
With what is your light source? Wait, I think you're muted. Was it a phone?
Yeah, it's a phone.
Okay, so it might not work with a phone flashlight, so if, I would just try and see if you have any stronger lights in your house. Any sort of light bulb or table lamp will probably work. So yeah, in case we didn't hear, the phone light bulbs don't seem to work, or the phone flashlights don't seem to work. So Nikhil, I'm not sure if you were here, but we've calculated that using a phone flashlight doesn't seem to work. So we're trying to find a stronger light bulb if we have one.
Okay.
I also think there's like one more thing that could affect it. I have lights like right above me on like the roof ceiling, and if I put the light right under, it won't do anything. So I have to like put like a thing over it and then shine the light.
Oh wait, could you show us in the camera what you did?
Yeah. So I have lights above me, and so I have this desk. Okay. Yeah, so I have this desk that's like this, and it has like a little thing. So I can't keep it out like this. I have to actually keep it in here, then shine the light.
Oh, got you. Thank you so much. So I'm pretty sure if like the room you're in is very bright, try to keep it out of other light and just direct the light from the flashlight to it. So is anyone seeing any sorts of changes? And then Maskeen, is anything working when you put it under the shield thing?
Yeah. I mean, I think my Q-tip writing isn't too good, but I can still like see like the words.
Oh, and what reaction is taking place, since in case the other people don't get to experience it?
It isn't really much of a reaction, but the light's kind of like making it easier to see.
Oh,
so
gotcha.
Maybe it's like, yeah.
So what was supposed to happen was that the lemon juice would darken. So once put under super bright light, there would be kind of a reaction again between the lemon juice and the air. And so the citric acid in the lemon juice would darken because the carbon within it would kind of break down and kind of like and leave to its own compound. And when carbon is by itself, it tends to darken. So like again, in other words, when exposed to like light and put under that energy source, the lemon juice kind of reacts with the air, and the carbon breaks down and just turns darker. And this relates to what we were learning because the carbon atoms in the lemon juice, once they're released into the air, they lose electrons once they react with oxygen. So yeah. All right, so it didn't seem that experiment worked. Oh yes, Maskeen?
It actually did work. So if you have like, this is my bowl, right? If I shine the light right in the bowl, it actually like changes. So the paper might not work, but you can just shine the light right in the bowl.
Oh wow. So does everyone want to take a second and try that? So is the experiment working for anybody?
For me, it's kind of like it provides more shadow, so I can see the writing more clearly. Like, I didn't see it darken that much.
That's interesting.
Yeah.
I'll tell the experiment designers that. All right. So I think the experiment didn't really work, but that's fine. I thought it was kind of fun anyways. So we'll move on to our 5 to 10 minute break. So the next thing we're going to learn about equations. So we have seen chemical equations before, but how do they work? So here on the screen, we have an example of a chemical equation. We have 2 hydrochloric acids and 2 sodiums, and then they rearrange, as we learned in a chemical reaction a few weeks ago, they rearranged into 2 sodium chlorides and 2 hydrogens. And so we're going to be doing a little bit of math work, but in case math isn't your favorite subject, that's perfectly fine. We're going to be doing like basic addition and multiplication. So yeah. So the first thing we're going to learn about conservation of mass. So what this means is that the number of the atoms on the left of an equation have to equal the same amount of atoms on the right of the equation. So what this means is that within a reaction, new molecules can be created, the atoms can be rearranged, but they have to stay. They don't disappear. They can create they can create completely different compounds, but those atoms in the reactants and the products, they have to stay constant, or else there's probably been a mistake somewhere. All right, and so before we kind of get into balancing equations, let's take a deeper look at what all the numbers within these equations mean. So here we have sodium chloride. So what does the 3, when you put it in front of that, in front of the sodium chloride, what does it mean? Pretty much, if the number's in front of it, it means that there are 3 of that type of molecule. So here we have 1 sodium chloride, and then when we put a 3 in front of it, we have 3 of them. So within an equation, if there's a number in front of the molecule or compound, it means there's 3 of that molecule or compound. And then we have H2O, and within that H2O, what does the subscript 2 mean? It means that within that one singular water molecule, there are 2 hydrogen atoms, because this 2 will correspond to the H. So it means that there's 2 hydrogen and 1 oxygen atom. And so here's a description. So one H2O has 2 hydrogens and 1 oxygen. All right, are we clear on what the 3, if the number's in front, or if the number's like subscript? We clear on what that means? Awesome. And so the next question is, how can we tell if a reaction is balanced? So again, within a reaction, the left side is the reactants and the right side is the products. So the reactants are what you have, what you start with, what you're combining, and the products is what is made, what they rearrange to be. All right, but within that chemical equation, we can see, I know it's a little confusing and the colors are kind of everywhere, but we'll learn more about what that means. So within the reactants, we can see that there are 2 hydrogens and 2 chlorines. So we can write down 2 hydrogens, 2 chlorines for the reactants. And then we can also see that there are 2 sodiums. So altogether, we have 2 hydrogens, 2 chlorines, and 2 sodiums. And again, what we're doing is counting the amount of compounds on the reactants and product side to see if it's balanced, right? So again, we saw 2 hydrogens, 2 chlorines, 2 sodiums. And then in the products, they rearranged and they created a completely different substances, but we can still see there are 2 sodiums, 2 chlorines, and 2 hydrogens. So was the reaction balanced? Yes. Why? Because they are the same amount of atoms on both sides. 2 hydrogens, 2 chlorines, and 2 sodiums. All right. So our next activity is we will balance these chemical equations ourselves. So the objective is that we will learn how to balance equations while following the law of conservation of mass, which, if we remember, is that nothing will be created or destroyed. So there must be the same amount of atoms on the reactants and the product side of the equation. All right, so for our experiment, we will need paper, 3 to 4 pens or markers, and scissors. Awesome. So, okay, don't get scared. There's a lot of text on the slide, but we'll break it down. So the first step is to write down the equation that we see on our paper. And again, leave some space because we will be doing several of these. So again, first step is to write down the equation, and I'll do it with you. So we have 1 zinc. All right, and once you have your equation written out on your paper, you're going to want to take 3 different colors. You can follow the ones on the screen, so like maybe blue, red, and yellow, but any 3 colors. And then we're going to count how many of each element there is on the left. So for example, we can see that there's 1 zinc, 2 hydrogens, and 2 chlorines on the left side. So we're going to label that. Is everyone clear on what we're doing? You can unmute yourself if you have any questions. So again, we're just counting down how many of each element there is on the left side of the equation. And once you're done counting, just give a thumbs up. And we'll move on to the next step. All right, so we can take a few more moments to count out how many of each element there is, or of each atom. And the next step is to cut out 1 circle per element atom. So personally, on the left side, I counted 1 zinc atom, 2 hydrogen atoms, and 2 chlorine atoms. So I'm going to cut out 1 circle for the 1 zinc, 2 hydrogens, 2 circles for 2 hydrogens, and 2 circles for 2 chlorines. And then we're going to label them out. And once we have all of our circles cut out, we're going to label them with the amount of elements that they have, or with the number of atoms they have that we counted. So once we have them all cut out and labeled, we want to rearrange them to see how many zinc chlorine compounds there are. So I want to make sure that we get to do more of these. So let's kind of, I think we're going to move on. So does anyone have an answer? How many zinc chlorine compounds there are? Yes, Roshan?
1 zinc chlorine compound.
Yeah, exactly. So is this the answer that everyone got? Ethan and Aparna, you guys look a little confused. Is there any specific points of confusion? No? Okay. So we're going to repeat the steps on the last slide. So everyone read out the equation, identify how many potassium, chlorine, and oxygen atoms there are, and then cut out the circles, and we're going to rearrange them to find out how many, I'm not sure what this compound is called, but we want to find out how many of them there are. Yes, Roshan?
Are there 3 of the the potassium, chlorine, oxygen?
Oh, did you cut out the circles, or?
Well, I'm not just doing it, but like I kind of calculated it.
All right. I was gonna cut out the circles to participate in the activity, but wait, how many did you say there were?
3.
Yeah, I believe so. All right, but we'll still try doing the experiment by cutting it out. And when someone has an answer, just feel free to unmute yourself and share. Does anyone have an answer to how many of the mystery compounds there are? All right, we still need a little bit more time. All right, maybe take another 30 seconds to cut them out and rearrange the circle.
It doesn't really make sense to me.
Okay, so here we'll go back on the other steps. So basically what we're doing is we are just counting out how many of each, number of each atoms there are, right? So in this, here, we'll go to which one we're currently at. So within the equation, we learned that this 4 means that there's 4 total of these, right? So within this, that means that there's 4 potassiums, 4 chlorines, and 12 oxygens on the left side of the equation. Right, because we learned that the 4 means that there's a total of 4, so they're each multiplied by 4. And so then once we count that out, we will cut out, 4 potassiums, 4 chlorines, and 12 oxygens, and then we will rearrange them to see, using what's left over, we'll see how many, I'm not sure what this compound's called, but how many of them there are. So I know it's a little bit tricky. But once we have the numbers, once we know that there's 4 potassiums, 4 chlorines, and 12 oxygens, once we subtract, yes, Nikhil?
I think I know how many mystery compounds there are.
How many?
3.
Yeah, exactly, yeah. So, awesome. And another way, which I think Roshan calculated it without having to cut out all the circles, is we knew that there were 4 potassium and 4 chlorines, but since we can see on this side that one of each is taken away, that means that we only have 3 potassiums and 3 chlorines left, which means that there has to be 3 of that mystery compound. But the way that we learned it is we are cutting them out. All right, so we don't have that much time left, so I think we will, who would like to take a little time to try and do the last one? Or do you guys think we have time? All right, let's take a few more moments just to do this last experiment, and then we'll wrap up and do the reflection form. Yes, Roshan?
I didn't cut it out yet, but I was just wondering if there's 3 of these hydrogen atoms.
You say 3 hydrogen compounds?
Yeah.
Yeah, I think so. And for anyone who's confused, it's because on this side there is a total of 6 hydrogens and 3 hydrogen compounds. 3 times 2 would be 6. All right. But again, we can take a few more minutes to cut it out and do it that way. And once someone finds it out by cutting it out, just let me know. And then once you are done, I think Roshan might be done, or he might still be cutting them out, but we can take some time to do the reflection form. So take maybe 1 to 2 more minutes to wrap this up, to cut them all out. And let me know if someone has an answer. How many more minutes do we need? Can I have it a number of fingers? 1 to 2? All right. Yes, Roshan?
Yeah, I finished cutting them out and I got 3.
Awesome. Did anyone else get this answer or was about to get this answer? Maybe? All right.